Hello and welcome to Oracle Enterprise Manager 12c Database as a Service RESTful API demo. First, let's understand what Database as a Service is. Essentially, it is a collection of services provided to service consumers. These services entail consolidation planning, application testing, service provisioning, elasticity, which will let you dynamically provision based on needs, service governance like access control, compliance, quota, chargeback, showback, and then finally ongoing operations and performance management. Now these services can be deployed on various database configurations. Some of these are dedicated databases, schemas in a large database, the new multi-tenant database 12c option where you can deploy numerous pluggable databases on a collection of containers, and finally cloning. Now cloning could be full clones using the traditional RMAN backups, or it could be snap clone or thin clones which can be created using various storage appliances or copy on write enabled file system. Now the final component to this database as a service offering is the infrastructure on which you can deploy these services and database configuration. So your choices extend from using commodity hardware, which could be physical or virtual, to running it on specialized database appliances like Oracle Database Appliance or engineered system like Exadata or Supercluster. Now we offer various choices in interfaces. You can either use the out-of-box self-service portal or the cloud portal, or if you would like to integrate the Oracle facilities with your custom portal or third-party tools, you can also use our RESTful Web Service APIs. So I mentioned we offer RESTful Web Service APIs. Now why would anyone want to use this? So a few examples is number one, let's say you have already invested in a non-Oracle self-service or a cloud portal. So you probably would like to integrate the Oracle services as part of that portal as well. You could also call these APIs as part of a larger orchestration flow. The larger flow could include approval workflows or integration with inventory or asset management systems. Another example is to call the cloud APIs via service desks or your ticketing systems. So there are a lot of users of cloud APIs or RESTful APIs, and then depending on your needs you can leverage them from third-party products, or you can write simple wrappers using any of the popular programming languages. So typically we deal with two classes of users. There are the DBS providers and then there are the DBS consumers. Providers are the class of users who administer and set up the infrastructure required to provide databases via a cloud portal or in a self-service fashion. So they are the typical cloud architects, the DBAs, etc. For this class of users, we offer EMCLIs, which is our own command line interface, or RESTful APIs. And you can perform CRUD operations on zones, pools, service templates, etc. All the concepts that you have to use to set up database as a service. If you are a consumer of this service, you have the option of using our RESTful APIs, and you can essentially operate on the complete life cycle. So you can list the various templates and the zones that have been defined. You can deploy different kinds of database configurations like we discussed, databases, PDBs, schemas. You can track progress. Once the services have been provisioned, you can schedule backups, you can do restorations, you can start, stop, control the state of the service. And finally, once you're done using these databases, you can delete them or you can extend the reservation to keep the service for a longer period. We use a resource-based API. So essentially there are different resources modeled. Everything that you see in yellow is an interface, whereas the three blocks in pink are the concrete implementations. So let's walk through this hierarchy. At the top is cloud, which is a overarching top-level resource. Now cloud contains various types of resources. The first in the middle is a zone. And as we discussed, zone is essentially a collection of servers, physical or virtual, or basically they are pools of infrastructure that would be used for provisioning your databases. Now on the left we have the service template. Now this is a critical concept and it lets you find the configuration, the exact configuration that you wish to deploy via the self-service or the cloud portal. Essentially, you define the end state of your database via the service template. And once you deploy a service template on a pool of infrastructure, or once the provisioning task is complete, you end up with a service instance. And these three blocks essentially corresponding to the three pink blocks as well. So you have a DBA zone, which is a collection of servers that are capable of hosting databases. Then you have the DB platform template, which is the database definition. So it contains the init parameters, the the HAD requirements, some post or pre-provisioning actions, etc., masking templates, all of that. Then once you deploy a template onto a DBS zone, what you end up with is a database or a schema or a pluggable database, and that is referred to as a DB platform instance. So since we are using RESTful APIs, there are various operations that can be performed on each of these cloud resources. A get operation essentially corresponds to a describe of the object or the describe of the resource. So the get operation is applicable on all these resources. Then the database zone and platform templates can be deployed, and hence they support the post operation. And finally, the DB platform instance, which is your database instance, you can do a describe, you can provision, and you can also deprovision, and hence it supports get, post, and delete operations. So with that, let's switch to a quick demo. So let's take a look at the graphical interface for the database as a service portal. So we'll log in as a consumer. Now this is a special interface designed for the cloud consumer. You can see various regions, the services on the left, then the usage against set quota below that. On the right hand side, at the top you see the three databases that have been pre-provisioned by this user, and then below that the requests that were scheduled to create the above three databases. So requests typically can be of multiple types. You can create databases, you can delete them, you can schedule backup, start, stop, etc. All these actions are modeled as requests. So as we look at the API demo, there are various things we will see that correspond to this interface. Firstly, we look at the number of requests. There are about 5 requests. There are 3 instances. And now if a cloud consumer wanted to request a new database, they click on this button, which is request new service. They would see a list of service templates. Now these have been decided by the providers and pre-approved by the providers. So this is a select set that has been exposed just to me via role-based access control. So let's just select the first one. Now the name of the template is bronze service single instance database, so it's pretty obvious what I get when I submit this request. I'm required to provide certain mandatory inputs. The first one is a zone. There's a single zone, and then I can provide a database SID. I can provide a service name, a schedule, credentials that I would use to access the database or log into the database. And there are certain optional inputs like the target properties or the service instance properties. So if you count these, there is zone 1, SID 2, service 3, credentials 4 and 5. So there are essentially 5 mandatory inputs. Everything else is optional. Now we come back to the portal page. You also have the option to click on any of these databases and get a view of their state and then certain metrics that have been collected for it. So the typical metrics that you would see are uptime, version, the available space, SGA, the connection string, any backups that have been scheduled, and a bunch of other details. So let's go back to the page. So that's a quick overview of the graphical interface. Now let's switch to the APIs. So now we are looking at the RESTful APIs. As I mentioned earlier, RESTful APIs are fairly simple to use, and you can call them directly either from third-party products. Most of them have predefined interfaces so that you can just plug in the inputs required. Or you can write a simple wrapper script in any of the popular programming languages. Finally, you can even call them from your shell. Essentially, commands like curl will let you call any RESTful APIs. Now, in this case, I have written a simple Python wrapper that will help me call the EM database as a service RESTful APIs. Now, the point of this demo is not to really showcase the Python program, but I'll just highlight a few things that I've used, and I'll also make this sample code available on one of the public repositories so that you can download and take a look at it. Now, there are certain prerequisites. So we require that you at least have Oracle Cloud Application Plugin version 12.108 or higher. In terms of EM releases, this would correspond to Enterprise Manager 12c release 4 and above. So it's important to be on the latest and greatest release. Secondly, I'm using Python 2.7. Any version of 2.7 is fine. I have used 2.7.3 specifically, and that's the URL if you wish to download the same. And lastly, I'm using a special Python package, which is http lib2, and again, I have the URL if you wish to download and apply that package. So in terms of the script itself, it's a very simple script. It's about 200 lines of code that includes white spaces and all the comments that I have. So in terms of inputs, essentially we require a few basic inputs. Like we require the EM URL and the EM credentials. So this is similar to the way you log into your browser. Next, if you remember the demo I did for the graphical user interface, we first selected a template from the service catalog, and the name of the template was Bronze Service Single Instance Database. So I provide the same name. Then I deployed it to a zone. And if you recollect, the zone is a collection of infrastructure. And then I provide a few mandatory inputs like the DB SID, the service name, and the database username and password. So these were the 5 mandatory inputs that we had to provide. I provide 6 examples or 7 examples here, and instead of me reading this out, let's just look at the output. So let me execute this script, and let's look at the output here. Okay, so as we scroll up, the first call that we made via the RESTful APIs is to get a list of all resources in the cloud, right? So we established a connection with EM using the URL and the EM credentials, and then we made a call to the cloud. So if you look at the request body, essentially we are doing a get. We pass in the credentials. We use basic auth for authorization, and then the URI that is used is /em/cloud. Now, since Enterprise Manager supports various cloud services like infrastructure, various middleware products, databases, etc., doing a get on the cloud will return a lot of output. Essentially, it will return all the artifacts that have been provisioned via the cloud portal across all these different services we have. Now, that is quite a lot, and considering the focus of this demo is on databases, we can filter this output further. So if you look at the output, which is returned in the JSON format, this is a popular format, and it's extremely easy to parse this output using any programming language. So essentially there's a resource type called service families, and this family includes Java service, database as a service, and infrastructure as a service, etc. Essentially what we'll do is, instead of doing a get on cloud, we'll do a get on the database as a service family, and that's the second API call that we perform. So let's do that. So now this is our second example, and let me scroll up again. Okay, so this time we did a get on EM Cloud Service Family Type DBAS. So now the output that I would see via the JSON output that I would see will match pretty closely with what you see in the UI. So you see the instance types we support. You can see the name of the service family. Then there are various service requests. If I remember correctly, there were 5 that we counted. So you can see the same 1, 2, 3, 4, 5. And there are a couple other ones which were backup related that are typically hidden from the main cloud portal page, and they're visible only on the specific database instance page. So that's why our count is a little off since we didn't count those, but there are 7, which is pretty close to what we have. There are various service templates that have been made available, and then lastly there are various zones. And if you recollect, Salt Lake City zone is what we have been using for provisioning. So in the end, there's a quick summary. There were 7 requests discovered. There were 2 zones and 10 service templates, which sounds about right. So let's move on. So the next thing we do is, instead of querying all the artifacts under the DBS family, we have the ability to filter the output. So here's an example of how to use filters. So this is similar to the call I made before, that we are querying the service family type DBS, but this time instead of getting the entire output, I just say that filter and show me only the service templates. And if you wanted to see more than service templates, you can provide a comma separated list, so only those elements from the JSON result are returned to you. So here's the service templates again. Let's move on. So the next API call is to list all the database instances in my portal. So again, if you recollect, there were 3, and so we correctly discovered that there are 3 instances. And if you look at the request body, this is slightly different now. So essentially we're doing a get on various zones. So I should probably explain this a little. So the way you fetch all the service instances or all the databases provisioned via the cloud portal is, number 1, you can get a list of all the zones that are available for database provisioning, and then query the zones for the list of instances deployed on that zone. So that's one way. The second way to do it is to get a list of all the service templates and then fetch the service instances by template. So typically in most customer cases we find that there are fewer zones than templates, so it's probably a little more efficient to query zones, and that's what I've done. I have 2 zones in my system, so this is the first one and this is the second one. So I queried both these zones and I fetch and show a cumulative list of all database instances that are available in my for this user. So let's move on. So now we get into now we are getting into the flow of provisioning or a database or requesting a service template be deployed. So before we deploy the database, we need to select a service template, and that's where what we have done is we have done a get, and here's the request body. Essentially we do a get on the desired service template. So if you recollect, we in the graphical interface we had chosen the service template bronze service single instance database. So via the APIs we do a get on the same resource, and now we can see various details about this service template. The service template was created on this date, this is the time, and there are various inputs that are required, like the master account, username, password, the SID, service family, etc. So all these details are provided regarding the service template, and the important thing to note is this special flag called require. So this will tell you if this is a mandatory input or if it's an optional input. Right, so you can look at the various list of attributes we support, and then towards the end there's also a summarized list. And for this template, the 4 mandatory inputs in addition to the zone are the database SID, the service name, and the username and password for the database. What this output also tells me is that 2 service instances have already been deployed using this template, and also it tells me that there is 1 zone registered with this template, and that zone is called Salt Lake City, and that's what I'll be using for provisioning. Let's submit a request for the database to be created. In this example we have provisioned the selected template on the desired zone. And so if you look at the request body, essentially we are doing a post on this URI, which is we chose the template, which is the bronze single instance, and then we did a post on this template, and then the inputs provided to this template were the zone and the four values that we cared about, and these are the values that were essentially provided: the zone name, the SID, service name, and credentials. So as the output indicates that the request was successfully submitted and it's now scheduled. So if I were to revert to my user interface and I refresh this page, I should find another service. Okay, so here's a request that has been submitted, and this will take a few minutes to complete. Now to check status, let's go back to our API. Now I can check status of this request via APIs as well. So let's look at that. Now for this, to track progress of the DB request, all we do is do a simple get on the database instance. So if you look at the request body, we're doing a get on the DB platform instance URI, right? And that's the request ID. And the output, again, the JSON output return essentially tells me that this is the name of the request and the status is still in progress. So I have a little wait loop here, so it waits for 60 seconds and it tries to check status again until it changes from in progress to running. So let's pause the video and give this process a chance to complete, and then we'll take a look at the final output and then conclude the demo. So the request is now complete. We see a lot more output than before, so let's scroll up here. After many attempts, the process was finally complete and it came back. So on a provisioned database, the output has more values. So you can look at the total number of allocated sessions, the active sessions. You can see which template it was provisioned of, the connection string, the version, the database version, the date it was created on, the zone, and many other metric values like the uptime. Since it was just provisioned, the value is of course 0. You can see the memory space, CPU utilization, CPU count, etc. So a lot more detail, and the key is that you can now see that the status is running. And if I were to switch back to the portal, so we can now see that a new database has been created. So the count went up from 3 to 4. With that, we conclude the demo. More information can be obtained about database as a service or APIs on our OTN page, and you can always refer to the Cloud Administration Guide for details on how to set the product up, and you can also find a lot more examples regarding the API in the documentation. Enjoy. Thanks.